Hello, AP Calculus students. It's Mr. Ford here with another summer packet tutorial. And today we're talking about topic S, special angles, which is probably, of all of the trigonometry that you've learned in your pre-calculus days, of all those formulas that you might have memorized, all those different triangles that you know, this is the thing that you probably need to know the most of that to be successful in AP Calculus. And what we're talking about here are the special angles that are around a unit circle, which I have, of course, placed for you right down below where my little video box is, just for our own reference here. We'll talk about this just right now before we get started. Okay, so as we ended the previous video with, there are special triangles out there. We call these 30, 60, 90 triangles. We also call them 45, 45, 90 triangles. And these triangles have some special properties that make them really easy to deal with when it comes to finding sines, cosines, tangents, and so forth of any sort of multiple of 30 or 60 or 45 or whatever. The way it works, since let's pretend that circle or that angle right there is the main angle. In a 30, 60, 90, let's focus our attention on this triangle first. The shortest side, which I like to call S, if that is equal to 1, then the hypotenuse, which I like to call H, will be 2. There's going to be a 1 to 2 relationship between these things. Actually, I reverse course now because in a unit circle, the hypotenuse is always 1, and that means the shortest side will be 1/2, since there has to be that 1 to 2 relationship. Now, the medium side is probably the trickiest one. Now, I could do a proof of this. I could show you a Pythagorean theorem calculation and show you that I'm not just making things up off the fly, but you'll just have to believe me for the purposes of length of this video. The medium side has a relationship that it is the square root of 3 times the shortest side. Square root of 3 times the shortest side. Since the shortest side is 1/2 in this example, that means that the medium side is the square root of 3 divided by 2. Now we can take the same exact triangle and we can flip it and make it a 60, 30, 90 triangle. Like this. And now the different pieces just move around. This is still 1/2. This is the square root of 3 over 2. And this is still 1. Now what that means for us, let me bring my unit circle up to the forefront here. What it means for us is that if we're looking at something like, say, the sine of 30 degrees, well, there's a little kind of invisible right triangle right there in this drawing. And that right triangle would have a vertical, or a y value of 1/2, and a horizontal of the square root of 3 over 2, which is why I would say the cosine is square root of 3 over 2, and the sine is 1/2. If there's anything you're worried about not taking with you into your calculus days from pre-calc, this is probably the thing that you want to focus the most on. These basic unit circle values. These will be assumed on the AP Calculus test. They will assume that you are aware of these angles, and probably those angles only. Now, the other one we should talk about for a minute is the 45, 45, 90. This one has a unique property where these two sides are the same. Now, of course, these being unit circles, the hypotenuse becomes 1, and so we end up solving this little algebra problem where these are both x. So we get x squared plus x squared equals 1 squared, if you're following the Pythagorean theorem. This means that 2x squared is equal to 1. That means x squared is equal to 1/2, and x is equal to the square root of 1/2, which we commonly write as 1 over the square root of 2. And then we do this little fun process where we rationalize that denominator. We multiply by the square root of 2 over 2, like this, square root of 2 over square root of 2. And the answer becomes the square root of 2 over 2. Since on the bottom there, the square root of 2 times the square root of 2 is just 2. Now, what this means for us in the case of this triangle is that the x and the y, or if we're thinking about this like trig students, the sine and the cosine are both going to be square root of 2 over 2. And you'll notice if you're looking at that unit circle that you have, hopefully somewhere, maybe hopefully in your brain at this point, but it's okay if you need to go look it up. Goodness knows I do. You'll notice that the pi over 4 angles are the ones where the x and the y have the same number, but they are opposites or positives and negatives, something like that. It would be a good idea for you to get a, I'm over in the wrong window. It would be a good idea for you to get a unit circle. You can easily find one by just Googling it and have it somewhere where you can see it while working on this particular worksheet. I'll leave that one right there, and it will stay there at the bottom of this. Now, number one, let's jump into it. Number one, it's worth mentioning that you could do this problem using another method. You might already know that this must be equal to 1, since the only trig identity you should ever memorize is sine squared plus cosine squared equals 1. But we'll show you what's going on here. Now, it also should be noted that the AP Calculus test does not use degrees in any way. Once we start our calculus adventure, we will switch to radians and keep it there forever. So you will not see 120 degrees. On the AP Calc test, you will see 2 pi over 3, but who cares? So, looking at our unit circle, we could, of course, draw pictures for this. I don't know how beneficial that would be. Maybe for this first example, but otherwise this video is going to be 40 minutes long, and I don't want it to be there. But 120 is going to look something like that. You're going to have a positive, square root of 3 over 2, and a negative 1/2, since, as we discussed in the last video, you are now in quadrant 2, where the sine is positive, but the cosine is negative. Anyway, not that it matters much. The sine of 120 is just going to be the square root of 3 over 2. The sine is always the y value. So this is the square root of 3 over 2 squared plus the cosine of 120, which is negative 1/2 squared. And if we do the math from here, squaring these fractions will give you 3 over 4 plus positive 1 over 4. And look at that. It's 4 over 4, which is 1. Which you might have already known that going into this problem. Let's take a look at another one. Now, don't let this problem scare you. All you're going to do is go on your unit circle and you're going to look up the appropriate values. Now, we do have a tangent involved, and that makes this problem kind of a pain. But again, I'm going to keep my unit circle kind of let me see if I can make it a little bigger, because I want to be able to read it with a little bit less difficulty here. Maybe make it just a little. Maybe I'll cover me up a little bit. There we go. That works. Just a little better there. Okay, so tangent of 300. For 300, we're looking down in the fourth quadrant, 5 pi over 3. Tangent is the ratio of sine to cosine. So we're going to do a little sub-math in this problem. Tangent would be, in this case, the negative square root of 3 over 2 divided by 1/2. That is and that, of course, is squared. Like that. We'll deal with that in just a minute. When it comes to 150, the sine of 150 is 1/2. So this is plus 3 times 1/2 squared minus the cosine squared of 180. These are the ones you especially want to know. Cosine of 180 is the x value, which is negative 1. So this is just negative 1 squared. Now, when it comes to dealing with this fractional bit, what I want you to see is that there is kind of a 1/2 multiplied on both these sides, and that 1/2 just cancels out. You can do a flip and multiply, and that will also cancel out the 2, but I'd rather have you see that the 1/2s actually cancel out. So we're going to have 2 times the negative square root of 3 over 1 squared. I guess I could put it there. Plus 3 times 1/4. I'm going to start working on this step by step. Minus 1. And that is subtraction, because negative 1 squared is positive 1, but it's being subtracted. So, and I'm going to, I should have left myself more room. Oh well. The negative square root of 3 squared actually becomes positive 3. And that becomes 2 times 3. This is 6 right there. Plus 3/4 minus 1. So this is all going to be 5 plus 3/4, or 5 3/4. Kind of like that answer. I'm gonna. I really wanted to keep that right with hair. Sure. Okay. All right. Well, I wanted to keep that right where it was. Oh well. Let's keep going. Question number 3. Again, we're gonna deal with some other stuff here. Cotangent. Okay. So cotangent is the ratio of cosine to sine. It's x over y instead of y over x. So at 135, this is an easy one, because we like when cotangents and tangents are being taken at the 45-degree angle. Anyway, so cotangent of 135, if I'm going the long way through this problem, is going to be the x over the y. It's square root of 2 over 2 divided by negative square root of 2 over 2. Of course, that's being squared. Sine squared of 210, well, 210 has a sine value of negative 1/2 squared, plus 5 times the cosine squared of 225. 225 has a cosine of negative square root of 2 over 2 squared. So we're just going to work through this now, and we're just going to cancel this out. Now, this is actually pretty easy, because this is just negative 1, and that's negative 1 squared. So that part is positive 1. Minus, we have a 1/2 squared that's going to become a positive 1/4, but it's being subtracted, so don't forget about that. And then we're going to have plus this mess over here, 5 times Well, when we square that, it'll become positive 2 over 4, which is just 1/2. Okay, it's not so bad then. So we're going to have 1 minus a quarter plus 5 and 1/2. I'm thinking there. As far as how to reason this out, well, let's call that, it's not 5 and 1/2, that's wrong. It's 5 times 1/2, which is 5 over 2. Okay. Well, if I make this all into fourths, what we have is we have 4 fourths minus 1/4 plus 10 fourths. And that is, all said and done, 4 minus 1 is 3, 3 plus 10 is 13 fourths. I love a good fraction problem when you can get it. There we go. Let's try number 4. Okay, now we got negative angles. So negative angles means you rotate around the angle clockwise instead of counterclockwise. So cotangent of negative 30 is the same. I'm just going to make a note up here. Cotangent of negative 30 is the same as the cotangent of 330. That's kind of the note there. Instead of going counterclockwise around the circle, you go clockwise. So you just go down instead of going up from your terminal angle spot. I can't write on this picture of the unit circle that I had down here, so unfortunately, otherwise I'd get it all marked up. Anyway, so we have the cotangent of 330. Now again, that's the x over the y, and I do not see a squared this time, so it's just what it is. X over y in this case would be the square root of 3 over 2 over negative 1/2. Plus 3 times the tangent of 600. Now we got to think about this for a minute. 600, I'm just going to make a note really quick, minus 360 is equal to 240. Now the thing about trig is that as you rotate around this circle, you end up repeating yourself infinitely over and over again. So in the world of rotation, 240 is equal to 600. They're the same angle. So this is equal to the tangent of 240, and that's exactly what I'm going to do. So this is tangent of 240, which is going to be the negative square root of 3 over 2 times negative 1/2, or divided by negative 1/2. Right there. And then finally we have the cosecant of negative 450. And again, what we want to do is take negative 450 and basically add 360 to it. And see if we land on this standard unit circle down below. The standard unit circle goes from 0 to 360. Anything that's outside of that range is a repeat. So we need to figure out what actual angle we're looking at here. Negative 450 plus 360 is going to leave us with negative 110. And if we add 360 again, in other words, spin around the circle one more time, we will land at, I think I made a math mistake there. Oh, it would be negative 90. Okay, I was backwards in my head. If we add 360 again to that, we will land now at 270, which is nice. So this is minus the cosecant of 270. The cosecant, of course, is 1 over the sine. 1 over the sine value. And the sine of 3 pi over 2, or 270, is just negative 1. So I'm going to get rid of these preliminary notes there, and so I have some room to actually do this problem. So when it comes to this first chunk, the 1/2s are going to cancel out here. So I'm talking about that 1/2 and that 1/2. They're canceled out. So now it's going to be this negative square root of 3 over 1 plus 3 times, let's see what's going to happen here. Same thing here. The negatives are going to cancel out, and the 1/2s will cancel out. So that is 3 times the square root of 3 over 1 minus, of course, that's negative 1. So thinking about what we got here and how I want to express it, we have the negative square root of 3 plus 3 square roots of 3 plus 1. So let's go ahead and factor the square root of 3 out of that stuff there. So that is the square root of 3 times 1, or sorry, let's see, factor, it would be negative 1 plus 3 plus 1. And of course, negative 1 plus 3 is 2. So this is 2 roots of 3 plus 1. That's my final answer. The fun thing, you can actually check this on a calculator. If you actually set your calculator in degree mode, which you should never do in the calculus class, but put it in degree mode and type this in, as it normally is, and then check it against 2 roots of 3 plus 1, you will get the same answer, I promise. Let's keep going. Okay, now we finally delved into Radian mode. So every angle in AP Calc will look like this. You will not have any degrees in this class. Good. So 2 pi over 3, 3 pi over 4, standard angles. Let's do the substitution first and then do the math. So the cosine of 2 pi over 3 is equal to -1/2. The tangent of 3 pi over 4 requires a little bit of work. Actually, it doesn't. Tangent of the pi over 4 angles is always going to be 1 or -1. In this case, since the let me move my mouse to show you. In this case, since the x value is negative but the y value is positive, tangent will be negative, also as we discussed in the previous video. So this is minus -1. This is all squared. So we got -1/2 plus 1 squared, and that is equal to 1/2 squared, which is equal to 1/4. That's my final answer. I'm putting my pin on that one. Number 6. Okay, this is one that, again, depending on how deep you got into trig formulas last year, you might already recognize this one, but we're just going to play with it like we don't recognize that at all, because the next video is all about trig identities. So let's just go ahead and plug these in. The sine of 11 pi over 6 is -1/2. The tangent of 5 pi over 6 is going to be trickier to get. That's going to be 1/2 over -√3/2. And again, we're just grabbing the y over the x at 5 pi over 6. That's where I'm getting the 1/2 and the -√3/2 from. We'll deal with that later. Sine of 11 pi over 6 is going to be 1/2. Actually, hold up. Let's put a pin in this for a minute. I got an idea. Let me back up a step. I think this would be easier to do if we just multiplied it together. Because watch what will happen. You'll get, if you do the distribution, you'll get sine times sine, and that's sine squared of 11 pi over 6. But then, look at what's going to happen. You'll also get, we're going to get a sine times a tangent, and then also the same tangent times the same sine, but it'll be negative. So those will cancel out. Ah, that's so nice. And then so at the end, we'll have minus tangent squared of 5 pi over 6. Okay, found ourselves a little shortcut there. Always thinking. Okay, now let's go back to the problem as we would normally. Sine of 11 pi over 6. This is 1/2, or I guess -1/2, but it's being squared. And now we have the tangent of 5 pi over 6, which we mentioned is 1/2 over -√3/2. That's all being squared. So -1/2 squared is 1/4. And let's think about what's going to happen here. Again, the 1/2s will cancel out, but this time it's a little upside down of what it was before. It's 1 over -√3. And that is, again, all being squared. Oh, I mixed my colors up too much. That's okay. So this is 1/4 minus, when we square that, that'll be -1/3. And it's being subtracted, so that doesn't change, but the negative square root of 3 goes away. So 1/4 minus 1/3. How about 3/12 minus 4/12, which was -1/12. Like that for an answer there. Pretty groovy. Okay, let's talk about true and false questions. Determine whether each of the following statements is true or false. So this is less about finding the answer and more about just thinking about, does this work or not? I mean, you could find the answer in this one. This is an easy one, to be fair. Over on the left side, sine of pi over 6 is 1/2. Sine of pi over 3 is square root of 3/2. But is that equal to the sine of pi over 6 plus pi over 3? It is not. That would be, let's see, this is 2 pi over 6. Would be pi over 3. So this would be 3 pi over 6, which is the same as pi over 2. So this is 1 plus √3/2, and then this is that equal to the sine of pi over 2, which is 1, which is not. So this is a big fat no. False. Number 8. Okay, again, this looks tedious and ridiculous, but if you break down for a minute, it's actually not too hard to work your way through it. Let's just get kind of a thinking pattern on how we're going to talk about this. Honestly, none of these are too hard to get, so let's just grab the 5 pi over 3. That's the angle we're looking at. 5 pi over 3 down on the fourth quadrant. Let's just plug those numbers in and see what happens. So the cosine of 5 pi over 3 is 1/2. 1/2 plus 1 on the top of that fraction. The tangent squared of 5 pi over 3, well, again, We might see the same patterns happening over again. This is the negative root 3 over 2 divided by 1/2. Of course, that's being squared. And we are seeing if this is equal to the cosine of 5 pi over 3, which is just 1/2 on its own, over the secant of 5 pi over 3 minus 1. And the secant would be the reciprocal of the cosine. Since the cosine is 1/2, the secant is going to be 2. This is 2 minus 1. I'm going to move this whole operation up to the side there and give myself some room to work with so I can think about it a little in more detail. So on the top of the left fraction, 1/2 plus 1 is 3/2. On the bottom, we are going to have, again, the 1/2s will cancel out like they do, right there and there, leaving the square root of 3 squared. We'll deal with the rest of that in a minute. And is that equal to, this is basically 1/2 over 1, so that's just 1/2. Okay, I think it is, weirdly enough, because here's what happens. On the left side, you got 3 over 2 on the top. On the bottom, you just have 3, and we're seeing if that's equal to 1/2. A better way to think about this would be 3 over 2 times 1/3, and look at that, it cancels out. The 3's cancel out at least. You get 1/2 and 1/2. So these are totally the same. Pretty groovy. Yikes. That's the kind of thing that when I was in high school, you spent a lot of time, and college, spent a lot of time proving things like that. But this is just an example. Oh, now here we go. This isn't actually a much easier question to answer than it looks like because of what this is saying. All we're asking here is this positive or negative? That's it. And oh, actually, we're checking it. A better way to phrase this question, is it positive? That's it. That's all we're asking. Is this going to be positive? Well, 2 in the front we can ignore. 2 is always positive. That's it. So the question is, are these going to come out to be positive or negative numbers? So let's talk about, let's leave the 2 there just for fun. We got 3 pi over 2 plus sine of 3 pi over 2. And the sine of 3 pi over 2 is negative 1. 3 pi over 2 plus negative 1. Now we have 1 plus the cosine of 3 pi over 2, and the cosine of 3 pi over 2 is 0. So what we've got here, that's positive, this is positive. So the question is 3 pi over 2 minus 1 positive or negative? Well, I got to think about this one for a minute. I can tell you it's going to be positive because I don't have a calculator in front of me. I'm not allowed to use one, but just kind of number sense, pi is about a little more than 3. So that's a little more than 9 on top of that fraction, and 9 divided by 2 is 4.5. So 4.5 minus 1 will be positive. So this is always positive. This is totally true. It's positive times positive times positive. It's always positive. Number 10 is going to be very much the same kind of question. Is it positive or negative? We basically have 3 chunks here, and all we have to do is decide if they're positive or negative. So let's start with the yellow chunk, the cosine cubed of 4 pi over 3. And all I'm going to do here in this problem, honestly, is talk about is it positive or negative. So let's think about the cosine of 4 pi over 3. 4 pi over 3 is down in the third quadrant, and you already know from the previous lesson that cosine is negative in that quadrant. And since you're going to take a negative number and raise it to an odd degree, it's going to be negative. So over here, I'm going to make my note there. That is going to be, you don't actually need to calculate it, but that is the negative square root of 3 over 2 to the third power. So a negative number raised to an odd degree is negative. Let's talk about the sine of 5 pi over 3, or 4 pi over 3. Is it positive or negative? It's going to be negative because it's in the third quadrant. We already know everything in the third quadrant is negative except for tangent. Cosine squared of 4 pi over 3 doesn't matter what it is. Squaring something always makes it positive. So it's positive. So this ends up being a positive number divided by a positive number, and that is a positive number. So this is also true. No actual calculation necessary for that problem. Kind of cool. You can actually do that a lot in calculus. You can get away with avoiding a lot of calculation if you're just good at thinking about what's going to be positive and what's going to be negative. And we'll talk a lot about that in this class. Okay, cool. That was a fun one. The top half, I got to be honest, not a super big fan. Some really bulky calculations in these first 6 problems. I would not concern myself too much. If I were you and I was struggling with this and I was like hitting my head against the wall in the summertime, just relax, man. Follow along with my notes. Just think about it. It's okay. This bottom half, I like it a lot. This bottom half is the kind of problem solving that we've been doing a lot lately. and the big changes here. So I especially like number 9 and 10. Really cool problems. Hey, another one in the tank, man. Another day closer to your senior year. Another day closer to an exciting time, an exciting class. I'm excited for you guys to be a part of it. Can't wait to see you in the fall. Hope you're having a good summer. I don't know about you, but it's 86 degrees. I'm going to go to the beach. So I will see you in the next video.